I have a gas here, and I'm going to expose this gas to what? I'm going to first pump more moles of the gas. So the first thing I'm going to do here is going to pump more moles of the gas. What happens to the gas volume if I'm just pumping more moles of this gas? The answer is simple. The volume of the gas increases if the number of moles of the gas also increases. Simply because of what? Simply because there are more particles, right? So again, the first relationship here I have is moles versus volume. And the greater the moles, the greater the volume is, okay? So let me write it here on the side. More moles equals more volume, okay? That's my first relationship. Second one is what? I'm going to change the temperature. This time, I'm going to take that gas here. I'm going to heat it up. You probably know this already, right? If you increase the temperature, what happens to the volume? Particles have more kinetic energy. They expand, and you would get more volume. So my second relationship here, more temperature or higher temperature equals more volume, right? Opposite is opposite. If you cool down, the volume will decrease, right? My last relationship here is pressure. You probably know this one as well, because pressure and volume are complete opposite. If you increase the pressure, if you squeeze the balloon, its pressure increases and its volume will decrease. So based on these things, I can construct a formula that would be very helpful to find moles, find volume, to find pressure, even to find the temperature. That's what we call the ideal gas formula. So take a look at my formula. It's this one here. P times V equals nRT. Remember, volume is directly proportional to temperature and moles, and volume is inversely proportional to pressure, okay? That's why the formula is written in this way. Now, what about R? R is a constant. R is what we call the ideal gas constant. It's just like a fixed number. So this R will be given to you in the question. And again, think of it like pi or any fixed number that we have. It's just, when we do these calculations, we're always considering that R is 8.31, okay? Now, the most important part here, or like the only tricky part about this thing here, is the units. You just have to make sure that each one of those givens in front of you is in the right unit. For pressure, we always assume that the pressure is in pascals, where 1 kilopascal, if it was given to you in kilopascals, then it will be worth 1,000 pascals, okay? So if I have to convert from kilopascals to pascals, I have to multiply by 1,000. Second thing is that the volume, that's one you have to be aware of it. The volume is meter cube, cubic meters. And if I am to convert here, like for instance, if I want to convert from dm cubed to meter cubed, what am I supposed to do? I have to divide by 1,000. If I am to convert from cm cubed to meter cubed, guess what? I have to multiply by 1,000,000. Just be careful, all right? Why million? Because I have to climb 1,000 and another 1,000 here, right? Again, it has to be meter cubed here for the volume. What about temperature? Temperature is in Kelvin, and you know this one probably from physics, that Kelvin is Celsius plus 273. The last one is moles, and moles you don't have to worry about because it will always be in moles, okay?